Good morning, my YouTube viewers. In this particular video, what we're going to be doing is we're going to be analyzing non-normally distributed financial metrics because this is going to be a non-parametric test. And so basically what we're going to do is we're going to write a program in Python to prove this. And in order to write the program in Python, what we have to do is we have to import some libraries. So we're going to import NumPy as NP, which is Python's numeric library, and it also creates NumPy arrays. And we're going to import Pandas as PG, which is Python's data processing library, but it also creates data frames and series. We're going to import matplotlib.pyplot as PLT, which is Python's visualization library. And from scipy.stats, we're going to import IQR, skew, and kurtosis. And so scipy is Python's scientific library, and stats is the statistical module within scipy. And IQR, skew, and kurtosis are three functions in the stats module. So after we have imported our libraries, then what we want to do is we want to simulate non-normally distributed financial data, and it's going to be revenues and profits in millions of dollars. But before we do that, what we want to do is we want to set our seed. And the reason why you set your seed is so every time you run the program, the variables will be initialized to the same values. So we set our seed by typing np.random.seed and any number you want within the brackets. So we're going to define the variable revenues equals np.random.exponential. So we're going to be using an exponential distribution, and an exponential distribution is skewed to the right. And the scale is 50 and the size is 100. So the size means there's 100 samples. And in profits, we're going to define the variable profits equals np.random.exponential bracket scale equals 10, size equals 100. So the profits are going to be much less than the revenues. And the reason why that is because you have to subtract the cost from the revenues to get the profits. So now we're going to create a data frame and call it financial data, and it equals pd.dataframe brackets, curly brackets, revenue, revenues, profit, profits. So revenue is going to be first column or 0, and profit is going to be the second column or 1. And the reason why that is because in Python, their numbering system starts with 0. So now what we're going to do is we're going to do some descriptive statistics. So summary stat equals financial data.describe. Describe is a function in Python that gives you some descriptive statistics of a data frame. And summary stats.loc IQR equals IQR financial data, axis equals 0. And axis, if it's a row, it's 0, and if it's a column, it's 1. So the axis equals 0 indicates that, no, I'm sorry, forget that. But it's just a financial data. It's a column of a financial data. And then the summary.stats.loc skewness equals financial data.skew, axis equals 0. And then summary stats.loc kurtosis equals financial data.kurtosis, axis equals 0. The thing about the IQR, going back to the IQR is interquartile range, and that's your median. So if you've been watching my previous videos, you know there's a difference between a mean and a median. So the IQR is the median, which is quartile 2, I believe. So now what we're going to do is we're going to print the descriptive statistics and we're going to print our summary stats. So we come down here to the bottom of the cell, and so you see that the descriptive statistics for the financial metric. So the count is 100, so that means there's 100 rows of data. The mean is 45 for revenue and 9.7 for profit, so that's the average. Standard deviation is 45 for revenue and 9 for profit. The minimum is 0.27 for revenue and 0.06 for profit. The 25% range, which is quartile 1, is 10 for revenue and 2.77 for profit. The 50% range, that's your IQR. It should be your IQR anyway. And that's quartile 2 is 31 for revenue and 7.04 for profit. The 75% range is quartile 3 is 65.5 for revenue and 14.5 for profit. The maximum value is 216 for revenue and 42 for profit. So your IQR is going to be, it says it's 54, so in theory, the IQR should be the Q3 minus the Q1. So 65 minus 10 is around 55 for the revenue. And then 14 minus 2.3 is about 11. So your IQR is your Q3 minus your Q1. So your IQR is not the same as the Q2, but the Q2 is the median, but that's what the IQR is. And then you check the skewness and then you check the kurtosis, and that gives you an analysis as well. So now we come back to the code. So we're going to visualize the data. So plt.figure brackets fig size equals 6, 4. We're going to create a histogram of the revenues. The plt.subplot brackets 2, 2, 1. plt.hist. So we're going to make a histogram of the revenues. Brackets financial data revenue, comma, bins equals 15, comma, color equals blue, comma, alpha equals 0.7. The title is revenue distribution. The X label is revenue in millions of dollars. The Y label is frequency. And the grid is axis equals Y, comma, line style equals dash, comma, alpha equals 7. So now we're going to make a histogram of the profit margins. So plt.subplot brackets 2, 2, 2, plt.hist brackets financial data profit margin, comma, bins equals 15, comma, color equals green, comma, alpha equals 0.7. And the title is profit margin distribution. The X label is profit margin in millions of dollars. The Y label is frequency, and the plt.grid axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. So now we make a box plot of the revenues. plt.subplot brackets 2, 2, 3. plt.boxplot brackets financial data revenue, comma, vert equals false, comma, patch artist equals true, comma, box props equals dict, face color equals light blue. The title is revenue box plot. The X label is revenue, millions of dollars. So now we make a box plot of the profit margins. PLT.subplot brackets 2, 2, 4. PLT.boxplot brackets financial data, profit margin, Bert equals false, patch artist equals true, box props equals dict, brackets face color equals light green. The title is profit margin box plot, and the X label is profit margin in millions of dollars. So we're going to show the plot. So plt.type layout and plt.show. So you can see this is the 4 graphs that we have made. So we made a graph of the revenue distribution and the profit margin, and you can see that the revenue distribution and the profit margin are skewed to the right. The reason why they are skewed to the right is because we made the synthetic data on an exponential distribution, and exponential distribution is skewed to the right. And then now we've made a box plot of the revenue and the profit, and you can see on the revenue and the profit box plots, you can see you have outliers. So that concludes this video. The next video is going to be another statistical subject, and I hope that you decide to watch it.